O means it will print the number in octal format. Okay. So what value it will print for second one? What is the octal representation of 58? Anyone? What is the octal representation of 58? How we can write 58 in octal format means how we can write 58 in base 8. Okay. So some students are saying 72, right? So it will print, what value it will print? 72. Now second one, what is the octal representation of 056? 056. What is the octal representation of 10? 1, 2. And what is the octal representation of 161? You are saying like that 240. Same like that, when you are writing percentile x means it will represent the number in hexadecimal format. Okay, so if you are going to execute the same program, just you can see what value it is printing. First, it is printing in decimal format 58, 46, 58, 46, 10, 161. Second one, it is printing in octal format 72, 56, 12, 241. And third one, it is printing in hexadecimal format. Third one, it is printing in hexadecimal format. If you are going to write the same statement, there is no any format for binary number. There is no any format for binary number. You cannot represent the number in binary format. If you are writing capital X, now you can see what are the changes you are getting here. Now, can you tell me what is the difference between a small x and capital X? Anyone? What is the difference? If you are writing a percentile a small x and if you are writing percentile capital X, what is the difference? So here it is coming in a small, here it is coming in capital. Okay, clear? So how we are going to print the value in octal, and if you are writing percentile D means it will print the value in decimal. If you are writing percentile D means it will print the value in decimal. If you are writing percentile O means it will print the value in octal. If you are writing percentile X means it will print the value in hexadecimal. Same like that, if you are going to write in simple number, that you are writing in the number in terms of decimal number. If you are writing 0 before the number means number written in octal format. If you are writing 0b before the number means number written in binary format. If you are writing 0x before the number means number written in hexadecimal format. If you are going to write here 2, what will happen? Same like that. If you are going to write here 9, what will happen? It will give you the compilation here. Now you can see this number is not valid. Okay, same like that. I am going to change to 6, and again I am going to check again. It will say this number is not valid. This number is not valid. Why it is showing this number is not valid? Because in the binary format you can only write 0 and 1. In the binary format you can only write 0 and 1. Okay, so this is the output of this code I am going to share with you. Okay, so in the previous class we have already discussed about the sign magnitude number. Sign magnitude means how we are going to represent the negative number, that we have already discussed in the previous class. Okay, so there are 3 different ways to represent the negative number. One is called the sign magnitude, second one is called the 1s complement, and third one is called the 2s complement. Okay, unsigned number, if you are writing unsigned number means you are writing positive number, then in this case for n bits number we can write 0 to 2 to the power n minus 1. The total number of distinct number we are writing 2 to the power n. Same like that, if you are going for the signed magnitude representation, sign magnitude representation for n bit you can write minus 2 to the power n minus 1 minus 1, 2 to the power n minus 1 minus 1. Okay, this is the code. Okay, how many total number of distinct number we are going to represent? 2 to the power n minus 1, because we are getting the 2 different representation of 0. One is for the positive 0 and second one is for the negative 0. Okay, so we are getting the 2 different representation of 0. One is for the positive 0 and second one is for the negative 0. Now the second case here, the normal addition is also not working. If we are going to write the normal addition, it will not work. Okay, so after sign magnitude representation, the researcher proposed one new representation for negative number, that is called the 1s complement. Okay, so what do we mean by 1s complement? So if you are writing any number, okay, the same like that here also the first bit is used to represent the sign, whether the number is positive or negative. So if you are getting 0 means the number is positive, and if you are getting 1 means the number is negative. Same like that. Okay. In the previous case, how we are going to find? Only based on that. We are writing 0 means positive, and after that we are finding what is the binary value or what is the decimal value of this binary number. And after that we are saying like this number is positive 5, this number is negative 5. Whatever the value we are getting, we are getting. Same like that 1, 1, 0, 0. What is the value we will get in the case of sign magnitude representation? First one, 1 means the number is negative, and 1, 0, 0 means minus. Okay, so 1, 0, 0 means if you are going to convert to the decimal number 0, 1, and 2, what is the value it will come? 2 to the power 2 into 1 plus based on the value it will become 0. So 2 to the power 2 it will become 4. So we are writing the number as a minus 4. But in the case of 1s complement, how we are finding the negative number? Just you can see, and this is very interesting. Okay, now I am going to write the first 2 bits number, then 3 bits number, and then 4 bits number. Okay, so 2 bits number, what are the possible combinations? 0, 0, 0, 1, 1, 0, 1. 3 bits combination, these are the possible combination: 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0. Okay, if you are going to write the 4 bits, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now we are writing 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1. So these are the combination basically we are getting in the 3 bits number, 2 bits number, 3 bits number, and 4 bits. Okay. In case of 1s complement, if we are going to find what is the value of minus x, okay, if we are going to represent any number called minus 10, minus 11, or minus x, then first we will find what is the binary representation of plus x. What is the binary representation of plus? So as for example, if you are interested to find minus 11, what is the binary representation of plus 11? Anyone can tell me what is the binary representation of plus 11? Anyone? First one, plus means the sign is positive. We are taking 8. Then we are not taking 4. We are taking 2 and 2. Can we write? This is the binary representation of plus 11. Can we write? Because the first sign, the first 0 basically represents the sign. And if you are writing 0 means the sign is positive. And 1, 0, 1, 1 basically represents for 11. How we are going to find what is the binary representation of 11? 11, 2 divided by 11. We are getting 5, 1, 2 divided by 5. We are getting here 2, 1, 2 divided by 5. We are getting 1, 0. So we will write in the reverse order 1, 0, 1. Okay. If you are going to find the 1s complement of this plus 11, then you simply flip the value. If you are getting 1, you have to make as 0, and if you are getting 0, you have to make as 1. So as for example, we have 1, so we have to write 0, 1, 0, 0, 1, 1, 0, 0, 1. This is the representation of minus 11. Okay, so there is no any direct way. To find the 1s complement. If you are going to find the, or if you are going to represent the negative number in 1s complement, then first you will find what is the binary representation of positive number, and simply you have to change 0 to 1 and 1 to 0. That will become the negative number. Okay, same like that. There is no any direct way to find the value. So as for example, if someone has 1, 0, 1, 1, 0, can you find if this number is 1s complement, what is the value of this number? There is no any direct way to find the value of this number. How to find? First we have to find the 1s complement, because we know this is a 1 is, this number is your negative number. If you are finding the 1s complement of this number, that number becomes positive number. So now we are writing 1 to 0. We are writing what? 1 to 0, then 0 to 1, 0, 0, 1. Can you find what is the decimal value of this representation? 0 means plus, and 8 plus 1, 9. It means this number is your minus 9. This number is your minus 9. Same like that, at least we will try. 1, 1, 0, 0, 1, 1, 1. Can you find? If this number is in 1s complement, what is the value we get? If this number is in 1s complement, what is the value we get? Anyway, what is the value we get? There is no any direct method to find the value. There is no any direct method to find the value. I have already mentioned, if you are getting x, if you are writing 1 as complement, you will get minus x. Again, if you are writing 1 as complement, again we get the value equal to x. Okay, x 1 is complement minus x 1 is complement, that become your x. Okay, so now we will find what is the value we will get. Anyone? What is the value we will get? So first, okay, first this number is negative because we are writing the 1 is definitely your number is negative, not a positive number. Okay, now we have to find 1 is complement of this negative numbers. We are getting 0 0 1 1 0 0. Okay, what is the value? This is your 24. So definitely this number is your minus 20. Definitely this number is your minus 20. Okay, so now we are going to write the value. What are the possible value we are getting? So 0 0. What value will write? First 0 represent the sign and second 0 represent the magnitude. So what value we are getting here? Plus 0. What value we are getting? Plus 1. Now we are going to find what is the 1s complement of 0 0. Can you tell me what is the 1s complement of 0 0? Anyone? What is the 1s complement of 0 0? 1 1 means this one basically represent minus 0. And what is the 1s complement of 0 1? What is the 1s complement of 0 1? 1 0. So this one represent minus. Same like that. Here we'll check. Here we'll write what value we'll get here. So we are writing here 0 0 means plus 0, plus 1, plus 2, plus 3. Now we are going to find what is the 1s complement of 0 0 0 1. So we are writing minus 0. What is the 1s complement of 0 0 1? 0 0 1 means 1 1 0. 1 1 0 means we'll write value equal to minus 1. This value equal to minus 2. This value. Same like that, if you are going to write here, that we'll write 0 1 2 3 4 5 6 7. It will come like that. What? Minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, and minus 0. Clear? Now, again, if you are going to write, if the number is 2 bits, what is the minimum number you are representing? Minus 1. And what is the maximum number you are representing? Plus 1. If you are going to write the range, can we write 2 to the power 2 minus 1 minus 1 2, 2 to the power 2 minus 1 minus 1. So here the range is same. If you are taking the n bits number, then we can write the range equal to same minus 2 to the power n minus 1 2, 2 to the power n minus, 2 to the power n minus 1 minus 2. Okay. So as for example, if you have the 10 bits number, what is the minimum value to represent? Minus 511. And what is the maximum value to represent? Plus 511. If we are going to write in 1s complement. Okay. If we are going to write in 1s complement, then in this case you can write the number equal to minus 5112 plus 511. Clear? Minus 5112 plus 511. But again, the problem is same. We are getting the two different representation of 0. One for positive 0 and second one for the negative 0. We are getting the two different representation of 0. One is for the positive 0 and second one is for the negative 0. And also there is one problem here. You cannot find the value of any negative number. Directly you cannot find the value of any negative number. In the case of sign magnitude, directly you can find the value. If this number is represented in sign magnitude, directly you can say like that. Plus first one your 1, you will write minus, and this value represents 4 minus 4. But in this case, you cannot write like that. First you have to convert to the 1s complement 0 1 1 0 1, and after that you have to find the decimal value. Then you get the value. No, that is not equal. According to the 1s complement, plus 0 is not equal to minus 0. According to the sign magnitude, plus 0 not equal to minus 0. If you are writing this statement, that will consider as a false statement, not a true statement. Okay, that's why we are getting the two different representation. That's why it consider as a false statement. Clear? Okay. Now here you can see the second problem. We will check whether the addition will work here or not. Okay. So now we are going to find here minus 3, or you can write minus 4 minus 2. What is the value we get? Minus 4 minus 2. If you are going to find the addition of minus 4 minus 2, what is the value we'll get? Anyone? Minus 6. Now, can you tell me the minus 6 is your result? If you are going to write minus 6, what is the minimum number of bits required to write minus 6 in 1s complement? What is the minimum number of bits required to write minus 6 in 1s complement? Minimum number of bits you are seeing. Okay. Now we are going to write what is the minus 4 in 4 bits number. What is the minus 4? First we'll write plus 0, 0. Sorry, plus 4 means how we can write plus 4? 0, 1, double 0. Can we write this here plus 4? Can we write 0, 1, double 0? Because the first basically used to represent the sign, and we are writing 0, 1, and double 0. If we are writing 0, 1, double 0, then after that, what is the 1s complement? 1 and 0, 1. This is called the minus. Now again, we are going to write minus 2. First, we write plus 2 in 1s complement. 0, 0, 1, and 0. What is the 1s complement? 1, 1, and 0. So we are writing 1, 1, 0, 1. This is your relation. Now we'll find the summation. 1 plus 1, what value will write here? What is the summation of 1 plus 1? 2. 2 we cannot write in the binary format, so we will write, subtract the base. 2 minus 2, 0. So we are writing here 0 and we will take 1 here. 1 plus 1, again 0, we are taking 1 here. 1 plus 1, again we are getting 0, we are taking 1 here. 1 plus 1 plus 1, we are getting 1, and we are getting 1 extra, so that will. So now what is the value we are getting here? 1,000,000. Can you tell me what is the decimal representation of 1,000,000? Anyone? What is the decimal representation of 1,000,000? Now we have to find the 1s complement. 0, 1, 1, 1. What is the value of 0, 1, 1, 1? No, I am talking about this number in a 1s complement. Directly you cannot find the value. So 0, 1, 1, 1. What is the value of 0, 1, 1, 1? Anyone? 0, 1, 1, 1. 0, 111. 4 plus 2, 6, 6 plus 1, 7. And if you are writing plus or plus 7, so this number is your minus 7. Now again, we have to check whether we are doing some mistake or what we have written minus 4, minus 2. Okay, the answer we are expecting here minus 6. Okay, right? How to write minus 4? First, we have to write plus 4. How to write plus 4 in 4 bits? Anyone? We are writing 0, 1, and double 0. What is the 1s complement? 1, 0, 1, 1. So this is your 1, 0, 1, 1. Okay. Now second one. Second case, we will go to the second case. Minus 2. What is how to write plus 2? 0, 0, 1, 0. 1s complement. 1, 1, 0, 1. We are writing 1, 1, 0, 1. What is the summation? Anyone? What is the summation? 1 plus 1, 0, we are getting 1. 1 plus 1, 0, we are getting 1. 1 plus 1, 0, we are getting 1. 1 plus 1, 3, we are getting 1 and 1. If we are going to find what is the value 1,000,000 in 1s complement, how to find? There is no any direct method. Just we will find the 1s complement. What is the value? 0, 1, 1. What is the decimal value of 0, 1, 1? Anyone? Plus 7. So this value is minus. Can we say this value or whatever the summation normal addition we are doing, that is giving the right result? Can we say? Can we say the normal addition is giving the right result? Okay, but if you are getting any overflow condition, if you are getting any extra bit, and if you are going to add again this extra bit, what is the value we get? What I am saying, if you are getting any extra bit, again you have to add this extra bit. What value we will get? 1,000,001. Can we get 1,001? We are getting one extra bit that we also call the overflow. And now we are going to add this overflow to 1. What value we are getting here? 1,001. What is the decimal representation of 1,001? If this number is 1s complement, what we can write? 0, 1, 1, and 0. What is the value? 6. So this value is minus 6. Means what we are saying like that. In the previous case sign magnitude, the addition is not working. But here addition is working. But you have to take the 2 steps if you are getting any overflow. If you are getting any overflow, it will not work in the single step. It will not give you the right value in single step. You have to continue for multiple steps to get the right value. This is the one advantage of using the 1s complement over the sign magnitude. But apart from that, there are also some disadvantages are there. What are the disadvantages? The first one, we are getting the 2 different representation of 0, and second one, there is no any direct method to find the value of negative number. There is no any direct method to find the value of negative number. Clear? There is no any direct method to find the value of negative. Clear? Now, after that, the researcher had proposed one new solution, that is for the 2s complement. And what is the 2s complement? 1s complement plus 1, that becomes your 2s complement. If you are writing 1s complement and then you are adding plus 1, that will represent your 2s complement. And nowadays we are only using the 2s complement. Okay. And now we will see what is the benefit of using 2s complement. Now we will see what is the benefit of using 2s complement. Okay. Okay. So now you can see again we are going to take the same thing, 2 bits number. If we are taking 2 bits number, these are also possible, 0 1 1 0 1. If we are taking 3 bits, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay. If we are getting 4 bits number, 0 0 0 4 5 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. Yeah. Clear? Okay. Okay. Now this, if we are going to write minus 13 in 2s complement. Okay. First I am going to write minus 13 in sign magnitude, minus 13 in 1s complement, and minus 13 in 2s complement. If you are going to write minus 13, first you have to find plus 13. What is the representation of plus 13? We are taking 8. We are not taking 8, 8. Then for 8 plus 4, 12. 2 we are not taking. Then can we say this is the representation of plus 13? Can we say? Can we say 0, 1, 1, 0, 1 is the representation of plus 13? How we are getting here? 0, 1, 2, 3. So 2 to the power 3, 8, 8 plus 4, 12, 12 plus 1, we are getting 30. What is the sign magnitude representation? Simply you have to change 0 to 1, 1, 1, 1, 0, 1. That is the sign magnitude. If we are going for the 1s complement, then you have to write 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0. That is the 1s complement, means this number is written minus 13 in 1s complement. If you are going for the 2s complement, again you have to add 1 here, 1 0 0 1 1, 1 0 0 1 1. That will represent minus 13 in case of 2s complement. That will represent minus 13 in case of 2s. Okay. Now you can see there is also a direct method to find the value of 2s complement. As for example, I am writing this one. Okay. Now can you tell me whether this number is positive or negative? Now assume that any representation we are using the sign magnitude of 1s complement or 2s complement. By looking this number, can you tell me what is the sign of this number? Positive or negative? Anyone? Negative. Why we are saying negative number? Because the first bit is 1. In all the 3 representation, the first bit 1 represent the number is negative. Okay. Now you will start the numbering from here. 0, 1, 2, 3, 4, 5, and 6. What we are writing? 0, 1. Okay. Only for the first bit, whatever the first bit number is there, only for the first bit number, I'm saying like only for the first bit, this one will write minus 1 into 2 to the power 6, and for the rest of the number we will write plus 2 to the power 5 plus 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 0 into 2 to the power 2 to the power 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Can you tell me what value will get? Minus 1 into 2 to the power 6, we are getting minus 64, plus this value becomes 0, plus this value becomes 16, plus 8, plus 0, plus 2, plus 1. What is the value we are getting here? Anyone? Can you please solve this expression? What is the value we'll get? Anyone? Minus 36. Now, can you please try the same step for this one? 10011. Same step. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. What we will write? For first number, we will write minus 2 to the power 4 plus 0 plus 0 plus 2 to the power 1 plus 2 to the power 0. What value we are getting here? Minus 30. Okay, what value we are getting here? Minus 30. Okay, now we'll try to understand one more example. Okay, 101100. Okay, 101100. Now assume that this number is represented in sign magnitude representation. Can you tell me what is the value of this number? If this number is represented in sign magnitude number representation, what is the value of this number? We are getting the 0, 1, 2, 3, 4, 5. Okay, so what is the value we are getting here? 0, 1, 2, 3, 4, 5. What is the value we'll get? Anyone? In the sign magnitude, 8 plus 4, 12. So we are getting minus 2. Okay, if this number is in 1s complement, what is the value of this number? If this number is in 1s complement, what is the value of this number? 0, 1, 0, 0, 1, 1. What is the decimal value of this number? Anyone? What is the decimal value of this number? Anyone? 19. So this number represented minus 19. Okay, if this number is in 2s complement, what is the value we will get? Anyone? Minus 32 plus 8 plus 4. What value we are getting here? Minus 32 plus 8 plus 4. What value will get here? Anyone? Minus 20. Now we'll check. Again, the same procedure will come. Okay, now you can see. If we are going to write 20, how to write 20? 20 in 0, how to write 20? 0. Then we will write, we are taking 16. Okay, 16. We are not taking 8. We are taking 4. Okay, 0, 0. Can we write? This is the 20 in a normal representation. Can we write? Okay. What is the 1s complement of this number? 1s complement. 1 is 0, 1 is 0, 1, 1. Can we write? If we are going to add plus 1, 1s complement plus 1, that becomes a 2s complement. What is the value we'll get? If we are going to add plus 1 here, what value will get? 1 plus 1 is 0, 1 plus 1 0, 0 plus 1, 1, 1 is 0, 1. Can we say this number is same like that? Can we say 1 is 0, 1, 1 is 0, 0 is this number is same like that, and here we are also getting minus 20. Means whatever the procedure we have discussed, that is also working here. Can we say whatever the procedure we have discussed, that is also working here? Can we say? Okay, now you can see. I'm going to write 1 is 0, 1, 1, 1 is 0, 1, 1, 1, 1 is 0, 1, 1, 1, 1, 4 times 1, 0, 1. Can you find if this number is 2s complement? Can you find what is the value of this number? Anyone? What is the value of this number? First one, 1 is 0, 1. Definitely this is your negative number. What is the value of this number? 0, 1 and 2. So minus 2 to the power 2 plus 2 to the power 0. What value we are getting here? Minus 3. Okay, minus 3. What is the value of this number? 0, 1, 2, 3. So minus 2 to the power 3 plus 2 to the power 2 plus 2 to the power 0. This value, what value will get? Anyone? Minus 3. If we are going to find this value, it will also come minus 3. And if we are going to find this value, it will also come minus 3. Okay, it will also come minus 3. Clear? Now, can you tell me, is there any difference between, in the real life, I am talking about the decimal number. If we are writing 75, 075, 0075, 00075, 4075, or 50075, can we say is there any difference between this number? Can we say no? If we are going to add 0 before the number will not change. Okay, in the real life, in the decimal number, if we are going to add 0 before the number will not change. Same like that in the 2s complement. For negative number, if we are going to add 1 before the number will not change. If you are going to add 1 before the number will not change. Here you can see whatever the value we are getting here, in all the cases, these values are coming same. As for example, sometime in the placement exam, it will come like that. 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, and 0. Now it will ask you, what is the decimal value if this number is in 2s complement. If this number is in 2s complement, what is the decimal value? What is the procedure? First, you have to find 1 such a way that after that all the values are 1. You have to find 1. After that, the left side, all the values are 1. Can we say what are the values here? Can we say this is the 1? Where after this, all the values are 1. Now we have to only consider up to here. 1, 0, 1, 0. What is the value of this number? 0, 1, 2, 3 minus 2 to the power 3 plus 2 to the power 1. What is the value we are getting? Minus 6 is the right answer. This is the representation of minus 6. You will get these types of representation or these types of question in your placement exam. Okay, as well as the gate exam. You definitely will get these types of question in your gate exam. So if you are going to check the question here. Same exam. Yeah. Now, can you find what is the value of this number? Anyone? Now you can see. Can you find what is the value of this number? What is the value of this number? Anyone? What is the value of this number? Anyone? How to find? First, you will find what is the nearest one. This is the one. You will only calculate for this one. So 0, 1, 2, 3, 4. Minus 16 plus minus 16 plus minus 16 plus minus 16 plus 4 plus 1. What is the value we are getting? Minus 11. Minus 16 plus 4 plus 1. We are getting minus 11. Okay. The same like that here also, just you can see. If someone will ask you to write minus 30, you can also write directly minus 30. Okay. Now we'll try to find what is the value of 2 to the power 0. What is the value we are getting here? 2 to the power 0. Anyone? 1. 2 to the power 1, we are getting 2. 2 to the power 2, we are getting 4. 2 to the power 3, we are getting 8. 2 to the power 4, we are getting 60. You have to continue this process until you are getting one number, 2 to the power that number that is greater than this absolute value of 13, or that is greater than normal 13. What is the value we are getting here? 16 is the 4th bit. So we are going to write 4th bit as a 1. If you are writing 4th bit as a 1 in case of 2s complement, how we are taking? Minus 2 to the power 4. What is the minus 2 to the power 4? Minus 16. What the value we have to add to minus 16 to get minus 13? Anyone? What the value we have to add to minus 16 to get minus 33? How to write 3 in this one? Your 4th we are writing. So 3, 2, 1, 0. How to write 3 in 4 bits number? How to write? 0, 0, 1, 1. Now you can see this is the representation of minus 13. How we are writing? Just again, I am going to give you one more example. Minus 25. What is the power of 2 such a way that that power value is greater than, slightly greater than 25? What is the value? 32. Just you can see 5. So in the 5th position, 0, 1, 2, 3, 4, and 5th position, we are writing 1. What value we will add minus 32 to get minus 25? What value we have to add? 7. What is the 7 representation in 5 bits number? 0, 0, 4 plus 2 plus 1. Now you can see 1, 0, 1, 1, 1. This one basically used to represent minus 25. Just you can see. Even directly you can find this value. Just you can see minus 21. Can you find what is the value of minus 21? Without 1s complement, without any calculation, directly can you write the value of minus 21? How to write? What is the minimum value? Yeah, what I'm saying. What is the minimum power of 2 such a way that that power is slightly greater than 21? Absolute value we are taking. Means minus 21, 21. So what is the value we are getting? 2 to the power 5. Now we will write the 5th position. 5th, 4, 3, 2, 1, 0. In the 5th position, we are writing 1. In 1s complement, what will become? Minus 32. What value we will add to minus 32 to get minus 21? What value we have to add? We have to add what value? Minus 32 plus 11. If we are adding minus 32 plus 11, minus 21. How to write 11 in 4 bits? We are not taking this one. 8, we will take 8. 4 will not take 8 plus 2 plus 1. Now you can see 1 0 1 8 0 0 1 1. This is the representation of minus 21 in this case. Okay. Now again we are coming to that place. Okay. Now you can see without any calculation, just will tell you what is the value. If you are writing 0 0, what is the value? Only the problem will come in the negative number. Only we will apply our mind on negative number, not for 0 0. What value will write? Plus 0 0 1 plus 1 1 and 0. What the value? If this number is 2s complement, what is the value of 1 0? Anyone? What is the value of 1 0? Anyone? What is the value of 1 0? Good. Minus 2. We are writing minus 2. What is the value of 1 1? 1 1. Not plus 2. Minus 2. 1 1 minus 1. 1 1 means how to find this value? Minus 2 to the power 0 plus minus 2 to the power 1 plus 1. What value we are getting? Minus 1. So we are writing here minus 1. Now we'll come to this one. 0 1 2 3. What is the value of 1 0 0? Anyone? What is the value of 1 0 0? Anyone? 1 0 0 minus 2 to the power 2 plus 0 minus 4. 1 0 1 1 0 1 1 0 1. What is the value? Minus 4 plus 1 minus 3. 1 1 0 1 1 0 minus 4 plus 2 minus 2. Triple 1 triple 1. What is the value? Minus 4 plus 2 plus 1 minus 1. Even if we are going to check what is the representation of 1? 0 0 1. What is the 1's complement of this 1? 1 1 0. If we are going to add plus 1, 1 1 1. Now you can see this is a minus 1. Now we are writing the same thing here. Okay. Now we'll come to this one. 0 1 2 then 3 4 5 6 7. What is the value of 1 triple 0? 1 triple 0. What is the value of 1 triple 0? Minus 8. This one minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1. Something like that. Okay. Minus 4, then minus 3, minus 2, and minus 1. Okay. Even if you have no any idea of this process, if you are going to write 0 triple 1, what is the number? 7. If you are going to find minus 7 in 2s complement, how to find 1s complement? What is the value of 1s complement? 1 triple 0 plus 1 and we'll add 1 0 0 1. What is the value? 1 0 0 1 that we are getting minus 7. Okay. So either you will use the direct method or you will use the indirect method. In both the cases it will. Okay. Now the second thing, what is the minimum value we are getting here? Minus 2. What is the maximum value we are getting here? Plus 1. Means if number is n bits number, what is the minimum value we are representing? Minus 2 to the power n minus 1, and maximum we are representing. Okay. If you have the 10 bits number, what is the minimum value we can represent? Minus 512, and maximum value we can represent 511. Okay. Now here we are not getting the two different representation of 0. We are getting only one representation of 0. That problem is also solved. So if you are going to take n number, the total number of distinct number you are generating 2 to the power n. But in the case of 1s complement sign magnitude, you are generating 2 to the power n minus. Now we'll check. Now we'll check for minus 512. It will not come 511. Just you can see. If we are taking 2 bits number, what is the minimum value we are representing? Minus 2. Yeah, minus 2. If we are taking 3 bits number, minus 4. If we are taking 4 bits number, minus 8. Okay. Now we are going to check minus 3, minus 2. What is the value of minus 3, minus 2? Anyone? Minus 3, minus 2. What value will get? Minus 3, minus 2, minus 5. For this result minus 5, what is the minimum number of bits required in 2s complement to write minus 5? What is the minimum number of bits required to write 2s complement in 2s complement? I am talking about the 2s complement. If we are taking 3 bits, right? 3 bits. What is the minimum number we can write? Minus 2 to the power n minus 1. What is the value? Minus 2 to the power 3 minus 1 minus 4. You can only write minus 4. You cannot write minus 5. Okay. So what is the minimum number of bits? 4. Okay. How to write minus 3 in 4 bits? But how to write minus 3 in 4 bits number? Anyone? First one. What value will take? Minus 4. In minus 4, what value we have to add to get minus 3? Plus 1. So 0 1. Okay, now we have to add 1 because we know if we are going to add 1 before the negative number, the number will not change. How to write -2? What is the minimum number of bits? What is the minimum number of bits? 2 bits. So we are writing here 1 0. This is a -2. We have to add 1 1. Can we add 1 1? Can we add 1 1? Or if you are interested to write, you can also write like that. Now +2. How to write 4 bits +2? 0 0 1 0. What is the 1's complement? 1 1 0 1. What is the plus add? 1 1 1 0. Now you can see I am writing 1 1 1 0. So either you will follow this as step or either directly will write. What is the summation of these two numbers? Anyone? 1 plus 0. 1. 0 plus 1. 1. 1 plus 1. 0. 1 we are getting. 1 plus 1 plus 1 we are getting 1 and 1 extra bit that we are going to delete. Okay. Yeah. Yeah, why we are taking 4 bits? Anyone? Why we are taking 4 bits? Because the output, whatever the output we will get, that we cannot represent using 3 bits number. -5 we cannot represent using 3 bits number. That's why we are taking 4 bits. Okay. -5 we cannot represent using 3 bits number. That's why we are taking 4 bits. That's why we are taking 4 bits. Now we will also see if we are taking 3 bits, what is the value we get. Now you can say, can you tell me what is the decimal number of 1011? Anyone? What is the decimal number? This one, -8 plus 2 plus 1. What value we are getting? -5. That is coming to the same. Can we say that here the normal addition will also work? Can we say the normal addition will also work? Can we say? Can we say? Yes. Okay. Now one student is asking if we are taking only 3 bits number, like 1. This is -4 0 1 and 1 1 0. This is your -3 and -2. Can we write 1 0 0 1 0 1 and 1 1 0? Okay. Now you can see. Just we will wait. Okay. Now we are using only 3 bits because whatever the number we are getting, we can write in the 3 bits. Now can you tell me what is the summation of this number? Anyone? What is the summation of this number? Anyone? 1 plus 0 1. 0 plus 1 1 and 1 plus 1 0, because we are going to discard this one. What is the value we are getting here? 0 1 1 0 1 1. What is the value we are getting here? 0 1 1. What is the decimal value? What is the decimal value of 0 1 1? What is the decimal value? Can we write +3? Can we write +3? Yes. Now you can see. If we are taking 3 bits number, we are going to draw this type of cycle. If we are taking 3 bits number, 3 bits number means what value we can represent? 0, 1, 2. If you are taking only 3 bits number, 3 bits number means what is the minimum value we can represent? 2 to the power 3 minus 1 and maximum value 2 to the power 3 minus 1 minus 1. What is the value it is coming? Just will tell me. -2 to the power 2 minus 4 and 2 to the power 2 minus 1 3. Can we say -4 to 3? If you are taking 3 bits number, can we say it will represent -4 to 3? We are writing like that. 0 1 2. Then we are writing 3. Okay, 0 1 2 3. Then we are writing here -4 -3 -2 -1. Now you can see this is just like one type of cycle. Okay. Now, if you are using 3 bits number, only 3 bits number, this is your 3 bits. Okay. So here, what is the maximum value we can represent? 3 and minimum -. But if we are giving the instruction to store 5, if we are saying you will store 5, what value it will store? Anyone? What value it will store? If we are giving to instruction to store 5, it will not give you the, yeah, just you can see. Yeah, addition is same like that. Whatever the addition we are doing the same like that. Just you can see. -3 -2. Now assume that. What is the output we will get? -5. What is the minimum number of bits required to store -5? 4 bits. Okay. So we are writing -3 in 4 bits. How to write -3 in 4 bits? First we will take 4 -4 plus 0 1 1. -2, how to write? 1 0 1 1. You have to add simple procedure. 1 plus 0 1, 0 plus 1 1, 1 plus 1 0, 1 plus 1 plus 1. 1 and 1 we are coming extra, that we are going to delete. If we are going to find the decimal value, we are getting here -5. Okay. Now the question is, if you are taking only 3 bits number, 1 0 1 and 1 1 0. Okay. 1 0 1 and 1 1 0. Okay. What value it will come? 1 plus 0 1, 0 plus 1 1 and 1 1 0. What is the value it is coming? 3. Now you can see how it will come like that. Okay. Now you can see what we are taking here, minus 3. Okay, just you can see the normal procedure. Try to understand what I'm writing here. If we are going to add any number to that number, you have to follow the clock cycle. And if we are going to subtract any number to number, you have to follow the anti-clock cycle. Okay. So what is the value we are getting here? Minus 3. We are getting here value minus 3. Okay. And then we are subtracting minus 2. Means we have to follow the clockwise or anti-clockwise. Just to tell me. We have to follow the clockwise or anti-clockwise. Anyone still tell me? If you are going to subtract the number from any number, we have to follow the anti-clockwise. And now you can see minus 3. If you are subtracting 1, it will come minus 4. If you are subtracting 2, it will come 3. Now you can see your output is also coming 3. Your output is also coming 3. Same like that. If you are writing here, simple, just you can see simple. 2 plus minus 3. 2 plus minus 3. Or you can also write 2 minus 3. Okay, right? What is the value of 2 in 2s complement? Anyone? How to represent 2 in 2s complement? Anyone? How to represent 2 in 2s complement? Simple. First one 0, 1, 0. Can we write? This is 2 in 2s complement. Can we write? Yes. How to represent minus 3 in 2s complement? Minus 3. Anyone? How to write? Minus 3. Can we write 1, 0, 1? Can we write 1, 0, 1? Minus 3. Can we write 1, 0, 1? Yes. Now you have to add these two numbers. What is the value we are getting here? 0 plus 1, 1. 1 plus 0, 1. 0 plus 1, 1. What is the value in 2s complement if we are writing triple 1? What is the value we are getting here? Good. Minus 1. Now you can see. What we are getting here? 2. Okay. Where is your 2 in this cycle? Just tell me. Where is your 2? This is your 2. Now we are subtracting minus 3. You will follow the clockwise or anti-clockwise. Anyone? We have to follow the clockwise or anti-clockwise. Anti-clockwise. Now will come. 1 time you are subtracting 1. 2 time you are subtracting 0. 3 time you are subtracting. You are getting minus 1. Now you can see your result. What is the output you are getting? Here you are getting also minus 1. Here you are also getting minus 1. Same like that. Just you can see. I am going to write here simple term. Character A equal to 128. Okay, and then we are writing percentile D, and then we are writing A. Percentile D, and we are writing A. Combine and catch. Now you can see what value it is giving. Just to tell me, I have written 121, but the output is giving minus 121. Can you tell me why it is giving minus 121? Just you can see. The character will take 1 byte of memory. Character will take 1 bytes of memory. It will take 1 byte. What is the number of bits? Number of bits in 1 byte. What is the number of bits in 1 byte? What is the number of bits? 8. If the number of bits equal to 8, what is the minimum number you can represent in 2s complement? What is the minimum number you can represent in 2s complement? Minimum number minus 128. What is the maximum number? 127. Can we represent 128? Can we store 128 in 7-bit number? We cannot store. So after that, it will follow the cycle. If you are writing 128, it will store minus 128. If you are writing 129, what value it will print? Just to tell you, 129, what value it will print? Anyone? If you are writing 129, what value it will print? Minus 127. Just you can see minus 127. Minus 127. If we are going to check what is the value, just you can see percentile D, and we are making the size of A. Just you can see what value it is printing. It is printing 1 bytes. It is taking 1 bytes of memory to store character value, to store the value of A. And if it is taking 1 bytes of memory, what is the minimum value it will store? Minus 128. What is the maximum value to store? 127. But we are saying like that we will store. If you are giving 127, what value will print? Just will tell you. If you are giving 127, what value it will print? Anyone? What value it will print? 127. Just you can see. 127. There is no any confusion. But if you are writing 130, what value it will store? What value it will store? If you are writing 130 minus 126, just you can see. Minus. If you are writing minus 128, minus 128, minus 128. What value will store? If you are writing minus 128, what value will store? Minus 128. Just you can see minus. If you are writing minus 129, what value will store? 127. Just you can see if you are going to execute, it will store 127. Clear? So how it is going to follow this cycle? I think you got the point. How it is going to follow this cycle? Okay, this cycle. You always follow this cycle approach. Okay. So now you can see if there is one question. Can you find what is the value we'll get here? Anyone? What is the value we'll get? Assume that the integer is taking 4 bytes of memory to store any number. If nothing is given, by default, this number is in 2s complement. So if this number is in 2s complement, and if you are using only 4 bits number, what is the value of minus 5 minus 4? Anyone? What is the value of minus 5 minus 4 if you are taking only this 2 bits number? Minus 5 in 4 bits representation. How to write minus 5? Minus 5 in 4 bits representation. Minus 5 in 4 bits representation. This is your minus 8 plus 3. So 0, 1, 1. Okay. And minus 4. Minus 4 minus 8 plus 4. 1, 0, 0. Can we write? Just we will add the summation. 1, 1, 1, 1 plus 1, 0. This value is the right answer. Plus 7. What is the right answer? Plus 7. Plus 7 is the right answer. If we are going to write the same number using the 1s complement, then we will get the different answer. Okay. But minus 5 minus 4, it will become minus, it will become plus 7. Okay. So in the next class, we will see about the more conversion called how to convert any base. As for example, base x to base pi. Till now, we have only discussed any base to decimal number, any decimal number to any base. Now we'll see how to convert any base x to any base y. How to convert any base to it. 1 bit, no, 1 bytes, 1 byte. I am saying 1 byte equal to 8 bits. 1 byte equal to 8 bits. By default, the compiler is using 2s complement. 1 byte is equal to 8 bits. I am not talking about the 1 bit. 1 bytes. This value is given in terms of byte. If you are writing size of A, it will represent in terms of byte. Now you can see 1 byte, not the bits. Clear? So if you have any question, then please ask. And next class is very important because we are going to see about the conversion of binary to octal, binary to hexadecimal. And directly how to convert any number to hexadecimal without finding the decimal number. Okay, so that is very important. So next class we will discuss some question, and after that we will discuss this one also. Now you can see what is the value of following signed binary number in decimal. If you are writing signed binary number, it's already given like the signed binary number. Means you are representing the number using a signed representation. So these types of question you can expect in your exam. This one, anyone can you tell me what is the output? The smallest integer that can be represented by 6-bit number in 1s complement. What is the smallest number you can represent in 6 bits number in 1s complement? Anyone? Minus 31. If you are writing 2s complement, what is the number represent 2s complement? Minus 32. Just you can see minus 32. Okay. So yeah, so in the next class we will see about the other conversion, how to convert base x to base y, and after that we will start the flowchart diagram. So in the next class for 30 minutes we will discuss about the conversion of base x to base. Cycle go clockwise when you are adding the positive number. When you are adding the positive number, the cycle will go clockwise, and when you are adding the negative number, the cycle will go anti-clockwise. Okay. So if you have any question, then please ask.